In the previous presentation, we had discussion on the electrical power in series combinations of resistors. Now in this presentation, we will be discussing some more examples about the electrical power in a series combination of resistors, in which the first one is a DC voltage source is connected in series with three resistors R1, R2 and R3, and we are asked to find out the resistance value of R1 and R2 and the power absorbed by this second component, and also the total power delivered by this DC voltage source. So the data which is given to us in this problem is RT, the total resistance of this network, is equals to 32 ohms, and the resistance of the third component is 1 ohms, and the power absorbed by this third component is P3, which is equals to 8 watt, and the power absorbed by this first component is P1, which is 16 watt. And the data which we are required to find out in this problem is the resistance across the first component R1 and the resistance of the second component R2 and the power absorbed by this second component, let's say P2, and the power delivered by this DC voltage source, let's say PE. These four terms we are going to find out for this network. Now before finding out the R1, R2, P2 and PE, we need to find out the total current in this circuit. We know that the current in the series combination is the same at every point in the circuit. So first of all, we need to find out the current in this circuit. So we can find out the current from this third component. So as we know that the power for this third component is equals to I square into R3. So P3 and R3 is already given to us. So we can find out I from this equation. So we get I squared is equals to P3 divided by R3. So P3 is 8 watt while R3 is 1 ohm. So after calculating, we get 8 ampere. Now taking square root on both the sides to remove the square from the current. So we get under root 8 ampere. So the resulting current in this circuit is 2.828 ampere. So 2.828 ampere of current exists through each component of this circuit. Now we also find out the resistance value of R1 from the power equation. P1 is equals to I square into R1. Now I is already given to us, which is 2.828 ampere, and P1 is also given to us, which is 16 watt. So R1 is equals to P1 divided by I squared. P1 is given to us, which is 16 watt, while the current is 2.828 ampere whole squared. So the resulting resistance of this first component is 2 ohms. So the resistance value of the first component is 2 ohms. Now to find out the resistance value of the second component, we have given a total resistance of this network and also R1 and R3, so we can easily find out R2. So as we know that the equivalent resistance for any series combination of resistor is equals to the sum of all the resistor connected in series. So the equivalent resistance is equals to R1 plus R2 plus R3. So RT, R1 and R3 are already given to us, so we can easily find out R2 from this equation. So R2 is equals to RT minus R1 plus R3. So R2 is equals to RT is already given to us, which is 32 ohms minus, so while R1 is equals to 2 ohms and R3 is 1 ohms. So the resulting value of R2 is equals to 29 ohms. So the resistance value of the second component is 29 ohms. Now to find out the power, that how much power is absorbed by this second component, let's say the power absorbed by this second component is P2, which is equals to I square into R2. So while I is given to us, which is 2.828 ampere square, and the resistance value of R2 is 29 ohms. So the power absorbed by the second component is equals to 231.9 watt. Of power is absorbed by this second component. Now to find out the total power delivered by this DC voltage source, first of all we need to find out the total potential difference across the terminals of this DC voltage source. So for that, as we know that from Ohm's law, E is equals to I into RT. So I is given to us, which is 2.828 amperes, and RT is 32 ohms. So the total potential difference across the terminals of this DC voltage source is 2.2828 into 32 ohms. So the total potential difference across the terminals of this DC voltage source is 90 volts. So as we know that the equation for the power delivered by this DC voltage source is PE, which is equals to I into E. I is given to us, which is 2.828 ampere, while E is 90 volts. So the total power delivered by this DC voltage source is 254.52 watt. 254.52 watt of power is delivered by this DC voltage source. So it's all for today's presentation. If you have any doubt, ask in the comment section. See you in the next one.